Okay, LeetCode problem number 100, same tree. Given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. All right, so example 1, we see we have first tree, root is number 1, children 2 and 3. Second tree, root is number 1, children are 2 and 3. So that is true. Second example, we have the root being 1 and one child as 2, and the second child is null. And then on the second tree we have root 1, first child is null, second is 2. So that's false because they're not identical. One's children is 2 and null, the second's children is null and 2. Okay, and the third example we have 1, children 2 and 1, and then the second tree is 1, children 1 and 2. So the children are reversed. So that is false. Okay. All right, so now we can go to the function. We can do a few checks before we even get into our actual calculations, and then we can do recursion. We can do recursively we can just call it a same tree function in our return statement. And we can use left and right. So we can do return our same tree, right? And then we will pass in the left and right of P. We'll compare the left of P to the right of P. And then we can do the same for Q. I think that should work. So we can do something like P left and then Q right. P left and Q left. And we'll do the same for the right side of these. So we're just going to traverse the left side for both and then the right side for both. And then we're just going to check if they're the same. That'll be the easiest way. If the left is not the same, that's already returning false, which is the bool. So what are we returning? Yeah, if they're the same or not. So are they the same or not? Is the left side the same? And then the right side has to be the same. If that's the case, that means we are good to go. We need to do some checks in the beginning though. And then this isn't really correct. This is just some pseudocode for right now, but that is the solution. What we want to check, if there are any nodes, we don't want to actually do any of this. So we should check the nullity. Is that a word? If they're both null. If P equals null and Q equals nil, that means we return true, right? Because they are the same. There's nothing there for both. And then if one is null, how would I write? If one is null, Okay, we can do something like this. Is P is, if P is null, this is 2 ands. And Q is not null. Then we just undo the opposite. Or if P is not null, if P is not nil, sorry, I've been writing a lot of Flutter recently. If P is not nil and Q is nil, we can return false. So we have if both are nil, if one is nil, let's see, this should work. Let's try and run it and see. Value of optional type tree node must be unwrapped to refer to member left of the wrapped tree node. Okay, so these are optional, so we can't use them directly. We have to do our unwrapping, so we can do some guardlet. Guardlet P tree equal P, and then we can let Q tree equal Q, and then we can do our else and return false. So that's safely unwrapping it, and then we just use these variables here instead of the ones that are being passed in. We could also just force unwrap it, but I was taught early on not to really do risky things like that. This is much more safer, and it should work all the same. You don't want your code to crash. Wrong answer for number 3. Return true. 1 2 1 1 1 2. It's gonna be this. I don't think I need to do the not nil part. Let's just do this. Okay, that's my mistake. Wrong answer again. Okay. Why is this returning true? If P is null and if P is nil or Q is nil, return false. We would do an regardlet. Given the 2 binary rights of function, if they're structurally identical. Oh, and have the same values. Okay. So this is returning true because we're not checking our values. So let's do our value check after our guardlet. So we can do if P tree dot val is not equal to Q tree dot val, we return false. Okay, so we were missing a step in the question. So we were checking the structurally identical, but we needed to check the values as well. And then we have a way to check up here. So that passes. So this one was fairly simple. We're recursively calling the function, and we're just checking the left side for each thing that's being passed in, and then we're checking the right side for each thing that's each tree node that's being passed in. And if they're not the same, that means they're not identical. That should be the first step. And then we're checking if either one is null. If they're both null, I mean they're the same, because there's both nothing. If either one of them is null, that means they can't be the same. And then we're checking the values as well. Okay, so let's submit it. Done pretty well. I don't trust it when it's 0, so no use. And let's look at some solutions. Recursion, easy. Easy to implement and understand. Okay, so this is checking if P is equal to nil and Q is equal to nil, return true. This is it. If P is equal to nil or Q is equal to nil or P's value does not equal Q's value, return false. So they combined these two. And they're also doing the recursion. So that was pretty cool. Also doing the same. They are force unwrapping. Not really good. Use stack to walk the tree. Okay, this is a longer way of doing it. Let's look at one more. Okay, so this is using a stack, removing last to get the current, and then checking the value, and then appending the stacks. Okay. All right, that was LeetCode problem number 100, same tree.